Ah, welcome. I hope that now you're starting to see how much physics is really involved in roller coasters and amusement parks and such, because when you are designing rides, and if you ever go to an amusement park, I just want you to understand that every single ride there is just an example of physics. Every ride takes one aspect of physics and turns it into a roller coaster or a spinny thing, but essentially amusement parks are essentially physicists just having fun. So I hope that you can never go to an amusement park again without thinking about, oh, when that first ride goes, they have to make sure it has enough energy so that it can overcome the next hill. You wouldn't want it to get stuck by having a lack of energy, so they must have calculated the dissipated energy and understand that when the ride returns and the brakes are applied, you can't stop the passengers too fast and have them fly forward based off concepts of inertia. I mean, let's be very clear. Amusement parks are simply a playground for physics folk. So what we're going to do today is get a little bit more into the math of these conservation of energy problems. Look at this. Now this looks similar to the work that you've done already, but there is one key difference, and this difference is going to be the crux of what we're going to learn today. The difference, my friends, is that I do not give you a mass. We have a ball rolling down a hill, and I want to be very clear that this is 4 unique points in time. I cannot stress this enough. Hopefully you guys get this now, that when you look at those problems, it's not like 4 different balls. It's one ball at 4 different points in time, rolling down the hill. There's no mass. But ultimately, the goal is to fill in these blanks. Every single blank. Well, I just don't know how to do that. Your tools are as follows. PE equals mgh. KE equals 1/2 mv squared. We should be getting good with these equations. I may not show all the math with these equations today because I will run out of space on my screen, and I don't think we need it. I can help you with what we plug in, but I'm not going to show you all the steps. Your first goal is to find the mass. We have to find the mass of this object because we can't get the TE without a mass because none of the spots have both a PE and a KE. So let's see how this is going to work. I need to solve for a mass. If I'm going to solve for a mass, I need a spot that has more than one piece of information. So I'm not going to look at spot 1 and I'm not going to look at spot 4. Those spots only have one piece of information. I'm going to focus on spots 2 and 3. One of these spots, I can solve for the mass. Can I solve for the mass if I have a KE and an H? Well, look at the equations. If I have a KE and an H, I can't solve for the mass because those quantities are in different equations. If you're going to solve for a mass and you have a height, you need to have a PE. So look at this. 900 equals mass 9.8 times 5. You need to be okay jumping around and solving problems out of order. You cannot just solve this in order like you would a normal problem. You have to be okay solving this in any order that makes sense. We have a mass of 18.37 kilograms. I rounded. You don't believe me? Do the algebra. Once you know the mass is constant throughout. So once you know the mass, the next thing that you have to do is get the total energy. Well, how can I get the total energy? Not one spot has a PE and a KE. Look at spot 3. It's got a KE and it's got a height. So I can use the height to get a PE. This is going to be problem solving puzzles. You are going to look around and you are going to solve for what you can given what you have. And I just said I wasn't going to do this. Come on, Bizzuto. Sorry, I'm teacher. All right. When I type that in my calculator, I get a potential energy of 756, I'm just going to say 0.11. So now I can get a total energy by adding these two up at the same spot. A question that I got the other day. So hold on, let's do that. Before I do all that, adding these two up. So my total energy is 1246.11 joules. What people asked me the other day, and I'm going to put this in red because you shouldn't do it red. Stop. They said, I have the PE and I have the KE. Why can't I just add those and get the total energy? In order to add the PE and the KE to get the total energy, it has to be at the same point in time. These are at different points in time. So if you added them, it's not very helpful. It wouldn't give you the total energy because some of the energy is transferred between these points. So these numbers don't pair together very well. So you cannot add PEs and KEs from different points in time. I had some people just adding them randomly. Do not do that. You must find the PE and the KE at the same point in time. And now that we've done that, take a look at this. Everything is just going to fall into place. So the KE here is going to be 146.11. The KE here for the second spot is going to be, I didn't need to do that. Why did I type that in my calculator? I actually knew that in my head. All right. 1, 1. And here, with the velocity, I could go ahead and use the KE equation of 1/2 18.37 times 10 squared. And I can get that the kinetic energy is 918.5. Yes. And then I could go ahead and subtract that from the total energy and get that the potential energy is 327.61. All right. So as the ball rolls down the hill, the PE goes down, which you expected, and the KE goes up, which you expected. And you could now solve for the heights and the velocities using the PEs and the KEs at the respective points. You know what? I don't think I'm going to do that in this video. I think you know how to do that. I'm going to do it just once. I'm just going to do it for spot 1 because I need to make sure you know how to get the heights. So PE equals mgh. The potential energy is 1100. The mass is 18.37. Gravity is 9.8. And height is what we're looking for. I plug all that into my calculator. We have a height of 6.11 meters. By the way, let's just look at it. Is that consistent with the heights that we have? It is. We expected this height to be bigger than the other heights that we had because that was the highest point on the hill. So don't be afraid to use logic. This does need to make sense. Don't just plug in randomly expecting that, okay, I got a number, so I'm just going to write it down. It's got to be the answer. Think logically. The kinetic energy is 146.11. Tell me, is the velocity here at the top going to be bigger or smaller than 10? We know it has to be smaller than 10. 10 is how fast it's going at the end, which is the fastest. So what we're going to do is we're going to take half of this, half of 18.37. Then we're going to divide both sides by the 9.185. And then I got to square root that, Jean. And I'm going to get 3.99 is my velocity. That's consistent. So we expect these velocities, you could solve for them. I don't think it's good use of time. We expect this velocity to be bigger than 3.99, but less than 10. And we expect this velocity to be bigger than this velocity. Trends, yes. Okay, so here we have a box falling to the ground. We need to get the mass, we need to get the total energy. Puzzles. Puzzles, puzzles, puzzles. I'm going to label it spot 1, 2, 3, and 4. Which spot can we get the mass? Well, you said we needed a PE and an H, right? Well, okay. Well, I don't have a PE anywhere at all. So we can't use PE and H. But we have another equation. We have KE equals 1/2 mv squared. Now, what quantity relates to KE? Height or velocity? Velocity. So we're going to use spot 3 to get the mass. You can use either energy. You have to be able to jump around and see what connects. So I know the kinetic energy here is 5.2. Wow, it's terrible handwriting. 5.0 equals 1/2 m 10 squared. 10 squared is 100. Half of 100 is 50. Yes, the half can jump through the m and take half of this square. Order of operations first. Divide both sides by 50. So you get 105 equals the mass. Once I know the mass, it actually gets a little bit easier. Because once I know the mass, I can now have to get the total energy. This is going to be the next thing I need to solve for. Can I get the total energy at spot 3? No, because I don't know the height or the PE. So let's look at spot 2. Well, I have the kinetic energy. So I can use the PE equation with the mass that I just got, the gravity that I've always known, and the height that is given. And I can get a PE of 9,261 joules. And then I can add it to the 1,500 at the same spot, and I can get a total energy of 10,761. So, once I have that, everything else falls into play. I can subtract to get this, subtract to get this. Every spot, the PE and KE has to equal 10,761. And then when I get my respective PEs and KEs, I can solve for the H's and the V's. For this first spot, I can use the height to get the PE. I can subtract to get the KE. I can use the KE to get the V. So, puzzles. Nothing here is hard. You just have to pay attention to what you have and what you're looking for. I'm not going to solve all that out, simply because people will just turn off the video at that point. Okay. In order to find the mass, this is just a quick little, like if you want clear concrete steps, now some people like clear concrete steps. If you want clear concrete steps, in order to find the mass, you need to find a spot that has potential energy and a height, or a spot that has a kinetic energy and a V. It's because if you think about the equations, you need to find things that pair together so that you would know these and these, so you could solve for the M, or you know this and this so that you can solve for the m, okay? So that's the first thing you need to look for, because you can't find the total energy until you find the mass. Finding the mass needs to be your first step. Once you have the mass, you need to find the total energy. Then what you want to do is you want to look for a spot that has one of the four following things. If you find a spot that has a PE and a KE, just add them up and you're good. If you find a spot with a PE and a V, you could turn the V into a KE using the equation, add them up and you're good. If you find a spot that has a height and a KE, you can use the height to turn into a PE, add them up and you're good. And then if you see height and a velocity, height goes to KE, H goes to PE, add them up and you're good. I hope you understand why I've spent so much time trying to think of the concepts. If you were just mindlessly looking at equations, it might be tougher to understand what you're supposed to do here. But if you really understand how these variables relate to each other, it's very logical. So that's it. I realized very recently, unfortunately, that we only have 4 class periods, including today, left. So after this assignment, we'll only have 3 class periods. So next week, we're going to learn the last little bit of energy, and unfortunately, that's going to be the last thing that I'm going to teach you. Well, last for the seniors. Juniors, you have another week with me. We'll do something special that week. But everyone is going to finish energy together, and then the week of Memorial Day, we'll take a test, an online test of all the energy stuff that we have learned online. So that's coming. I just want you to know, maybe you want to actually take some notes, organize your notes. Might not be a bad idea. Maybe you got a piece of paper where you write all the equations down, possibly. Units, I don't know, definitions perhaps. More information will be coming on that in the future, but I just want you to know that that's there. So if you haven't been taking notes on the PowerPoints, maybe this might be a good time to go back and write down some key ideas, maybe some calorie conversion factors or something. I don't know. I don't know. Maybe. But yeah, that's coming. We're going to get through this, you guys. Hope all is well. I'm here if you need me, and I will see you guys next time.